Hey guys, uh, in 1 minute we'll be starting the class. We'll be solving some questions at the end of the class, and the two questions will be from previous year GATE, and the two will be from ESE mains. Just 1 more minute and we'll be starting the class. Am I audible? Please comment down. Am I audible? Okay. Those who are meeting me for the first time, I am Tech from IIT Bombay, and I have 4 years of teaching experience, and I'll be teaching you heat transfer, thermodynamics, fluid mechanics, and engineering mechanics. Hi, good evening. Okay, engineering mechanics and RIP batch. Okay. Good evening, Vijay. Good evening, Arjun. वेंकी साई एमटेक इन आईआईटी बॉम्बे के बारे में कुछ बताओ। क्या जानना चाहोगे यार? पूछो, अपना क्वेश्चन पूछो, बता देंगे। वैसे भी मैं एक वीडियो निकालने वाला हूँ, एमटेक फ्रॉम आईआईटी बॉम्बे पार्ट 2, तो 2-3 दिनों में आ जाएगा वो। क्या जानना चाहते हो एमटेक फ्रॉम आईआईटी बॉम्बे के बारे में? कमेंट डाउन। Next, you can reach me on Facebook, on my Facebook profile for any query, for any type of query. Okay, and this group is a doubt solving group. Faculty project usefulness for future. Faculty is top class. In my department, there were 2 professors who were PhD from MIT, and one was even the gold medalist from MIT. And project usefulness for future. There are lots and lots of companies that come for recruitment there, core companies. And also if you want to go into PhD, तो PhD के लिए भी बहुत स्कोप्स रहते हैं वहाँ पे। एक बार IIT बॉम्बे का टैग लग जाता है और एमटेक में अच्छा परफॉर्म किया है तुमने, परफॉर्म करने का मतलब तुम्हारा CPI अच्छा है प्लस प्रोजेक्ट वर्क अच्छा है, ये दोनों अच्छे होने चाहिए। ओके, तो बहुत ज़्यादा चांसेस होते हैं कि अगर तुम्हें PhD बाहर से करनी है तो यू कैन गो फॉर अ PhD फ्रॉम अब्रॉड आल्सो। ओके, या सर फॉर IIT बॉम्बे गेट में कितनी रैंक चाहिए होती है मैकेनिकल गेट स्कोर मैं बता देता हूँ। If your gate score is above 850, I mean 200 or 300 all India rank, you'll get IIT Bombay Mechanical. AIR 200, 300, you will get IIT Bombay Mechanical for sure. Sir, XC के लिए there will be separate seats reserved. Yes, ऐसा होता है. Suppose in mechanical department there is this specialization design. Okay, so sometimes yes, some seats are for mechanical engineering students, and I guess in mechanical engineering department there are no seats as such reserved for XC or for any other branch, but in other departments yes, there are seats reserved. Like in metallurgy, some seats are reserved for metallurgy guys, and some seats mechanical guys can enter, and XC guys can enter, or physics guys can enter. Okay, you can check the brochure for this. Yeah, everything is given in the brochure. You can check the brochure for the same, right? So will you complete thermodynamics on YouTube? I will be completing thermodynamics part 1 on YouTube in this month, June, and I guess I'll be continuing the same, maybe thermodynamics part 2 in the next month, maybe. So thermodynamics part 1 I'll be completing here. Okay, so this AIR 1 sir, XC के लिए will there be separate seats reserved? That is what I told you, right? Yeah. In mechanical, I don't think so that there are separate sheets for XE, but you can apply with XE. XE is gate score in mechanical department, that is for sure. And if your gate score in XE is good, you'll get IT Bombay. If your gate score is above 850, 860, you'll get IT Bombay design. There's a lot of probability. Okay, so let us start with the lecture. But before starting with the lecture, do connect with me on my Facebook profile, and on Instagram you can follow me, and also you can follow me on Unacademy for my free special classes. Okay, I'm going to take free special classes on logical reasoning for NLC, Vizag Steel, and other, GATE, ESE, and other exams. Okay, let's move on with the class. So thermodynamic work, there are types of thermodynamic work. Okay, electrical work, pedal wheel work, shaft work, and then there is our PDV work. That is what? Displacement work. Okay, we'll be studying some theory, and then after some time we'll be solving some questions. Okay, we'll be dealing with some questions in this class. Okay, so electrical work, many a times you must have encountered this type of problem. Okay, suppose this is a room and this electrical work is now entering. Okay, so what is the value that you will be taking? Rate of work input is equal to VI. Okay, and work input will be equal to VIT or I square RT. R is what? The value of resistance. Correct? T is time here. Okay, please be careful. Time. Pedal wheel work, we'll be solving one question of this pedal wheel at the end of the class. Okay, one conventional question. Okay, pedal wheel work and shaft work, sometimes some problem is there and a pedal is there. Okay, so what is the expression of that pedal wheel work? T into theta. What is this T? This is torque. Theta is angular displacement, and the rate of work input is T omega, that is torque into angular velocity. Okay, this is the expression. How to use this expression, that I will be telling you in this class when we'll be solving the conventional question at the end of this class. Okay, don't worry. Same is the expression for shaft work. Okay. Now what is this PDV work? We'll be encountering this PDV work. This is basically displacement work, known as displacement work. Okay, so what happens? Firstly, let us assume that this is atmospheric pressure, and inside this cylinder there is a gas whose pressure is P1. Okay, the initial position of the piston is this, and the final position of the piston is this. Okay, so we have to go from state 1 to state 2. Okay, if I have to calculate the work done or work interaction from 1 to 2, can I use this formula, force into displacement, directly? Tell me, can I use this formula? This is my displacement. Can I use this formula? Tell me. P1 is greater than P18. Okay, tell me in the comment section. Yeah, piston displaces outwards. Can I say that work interaction 1 to 2 is equal to force into displacement? Can I use this formula? I can convert this force P into area. No, yes, you cannot use this formula. Why? because the pressure is continuously changing. The pressure is continuously changing, right? Okay, now what I will do is I will take a small element dx, okay, such that the pressure change is negligible. Okay, I take a small element dx such that the pressure change is negligible. So what will be the value of del w? What will be the value of del w? It will be pressure into area into dx, right? What is this area? Area is area of piston, correct? And this adx is what? This is change, a small change in volume, that is represented by dv. Okay, so small work interaction del w will now be p into a dx. Okay, this I can use because now I have considered a small element dx, that the displacement is small, so small, let it be dx. Okay, such that the pressure change is negligible. Okay, okay. And now if I have to integrate, if I have to find the total work done, what I will do? I will integrate it from 1 to 2, 1 to 2. Okay, and this will give me work interaction from 1 to 2 is equals to p dv. Correct? Correct? Is it fine? 1 to 2. I don't know why this is lagging. I just don't know. Uh, is it fine? Is it fine? Great. Okay. Now we encounter two types of questions. Okay, generally we encounter two types of questions. Let me tell you. Work interaction from 1 to 2 is equals to 1 to 2 pdv. Okay, first, if the pressure is constant, what you can do is you can take out this p and then you can perform your integration, correct? Secondly, sometimes a relation is given between p and v, correct? In that case, what you do is, suppose this is the relation p is equal to a plus bv. What will you do? You will put this relation here in place of p and then you will integrate to get your answer, correct? These are some, sometimes you will encounter this type of question as well. Okay, now if the relation is plottable on a graph, if a relation is plottable on a graph, the PV relation is plottable on a graph, suppose it's a linear function, suppose P and V vary linearly. Okay, so what will you do is you will plot this function on PV diagram, and whatever will be the area under this curve, it will give you the work interaction from 1 to 2, from 1 to 2. Okay, okay. Now there is one important point here. Please listen carefully. One important point. What is that point? When I'm, drawing this curve, I'm assuming that the intermediate states exist, correct? And for intermediate states to exist, the system should be in thermodynamic equilibrium. Okay, and when can be the system in thermodynamic equilibrium? In the case of quasi-static process. This is what I have explained you in the earlier classes. Okay, when I'm drawing this curve, okay, when I am drawing this curve, I am considering that the intermediate states are defined. Intermediate states are defined. Whenever a state is defined, that means the system is in thermodynamic equilibrium. Okay, what do you mean by thermodynamic equilibrium? I have clearly explained you everything, that within a system delta T delta P will be 0 and there will be no chemical composition change. Okay, so if intermediate states are defined, if I am drawing this curve, that means intermediate states are defined. Okay, that means the system is in thermodynamic equilibrium. The system is in thermodynamic equilibrium. Okay, and when can the system be in thermodynamic equilibrium? When the process will be quasi-static. Okay, so this is the most important condition to use this PdV formula, that the process has to be quasi-static condition. Process has to be quasi-static. Is it fine? Is it fine? Is it fine? Please comment below. Is it fine? Do like this session, mark your attendance, guys. Do like this session, mark your attendance. Is it fine? Correct, correct. Let's move ahead. Yes, okay. Ideal gas equation. Correct, correct, correct. Okay. So ideal gas equation, PV is equal to N R bar T. Okay. This was the equation we were studying when we were in 11th class. Okay. In our school days. Right. And in this equation, this is, what is this P? This is absolute pressure. Absolute pressure. V is in meter cubes. What is the value of R bar? R bar is universal gas constant and the value is 8.314 kilojoule per kilomole Kelvin. Okay, please see the units. Kilojoule per kilomole Kelvin. Okay, but whatever the equation, the ideal gas equation that we'll be studying in our thermodynamics is a little bit modified. Okay, so what we did is PV is equal to number of moles. The formula of the number of moles is mass of the gas upon molecular weight of the gas. R bar T. Okay, so what we did is this R bar by M is equal to R, that is characteristic gas constant. Okay, and our equation became PV is equal to mRT. Okay, correct. R is characteristic gas constant here. Okay, is it fine? For air, R is 0.287 kilojoule per kilogram Kelvin. How is it? How we have derived this value? See here, R for air is equals to R bar 8.314 kilojoule 8.314 kilojoule per kilogram Kelvin upon what is the molecular weight of the air? R bar is 8. Let me just correct it. R of air is 8.314 kilojoule per kilomole Kelvin. The molecular weight of air is approximately 29. Okay, approximately 29. That is kilogram per kilomole. Okay, so kilomole gets cancelled out and R of air becomes 0.287 kilojoule per kilogram. Please be careful with the units. Okay, please be careful with the units. Correct? Is it fine? Is it fine? Please be careful with the units. What is a polytropic process? Fine, okay. So any thermodynamic process molecular weight of the air is 28.97, but I have taken it as 29. Okay, so approximately it is 29. However, it is 28.97. Okay, so any thermodynamic process can be represented in this form: PV raised to the power n is equal to constant. What is this n? N is polytropic index. Okay, and C is what? Polytropic constant. Okay, so what we do is we vary the value of n and we'll be getting different processes. For example, isobaric process. Isobaric process means pressure is equal to constant. See this equation: PV raised to power n is equal to constant. If n is equal to 0, then only P will be constant. Okay, so PV raised to power 0 is equal to constant. That means P is equal to constant for n is equal to 0. Correct? Good evening, Amit. Good evening. Do mark your attendance. Okay, let's move on to isochoric process. Isochoric process, that is V is equal to constant. Okay, I say n is equal to infinity. When I put n is equal to infinity, then this process is there. Okay, when I put n is equal to infinity here, then volume will be constant. You will say, sir, how is it possible? Let us see. PV raised to power n is equal to constant. What you will do is PV raised to power n raised to the power 1 by n is equal to C raised to power 1 by n. Okay, this is what you will do. So P raised to power 1 by n, V is equal to C dash. This C raised to power 1 by n, let it be another constant C dash. Okay, now you put n is equal to infinity. What you will get? You will get V is equal to constant. This is how you get this result. Correct? Is it fine? Is it fine? Next, we deal with a standard process which is isothermal process. I don't know why it is lagging so much today. Isothermal process. Is my switch on? Yeah. So PV raised to the power n is equal to constant. This is how a polytropic process is represented. If n is equal to 1, then PV is equals to constant. Okay, from ideal gas equation, PV is equal to mRT. M is constant, R is constant, T is constant. Okay, if PV is equals to constant is the equation given to you, that means it is an isothermal process. Okay, this T has to be constant for this equation to hold valid. Okay, this T has to be constant. M is constant, R is constant here. So T has to be constant for this equation to be valid. Okay, let's move on to the other process. Adiabatic process. In adiabatic process, we put n is equal to gamma. What is this gamma? Ratio of specific heats. Now there is a very long derivation. There is a derivation about this, and it's of no use to us. So why waste time in doing this derivation? Okay. So in adiabatic process, n is equal to gamma, and what is gamma? Gamma is the ratio of specific heats. That is Cp by Cv. This you must be knowing, right? And polytropic processes represented by PV ratio. Clear up to here? This is an easy part, I guess. So everything will be, I think, will be clear to you. Correct? Please tell me in the comment section. Come on, tell me in the comment section, and then we'll be, getting the equations for work done in different processes, and then we'll be moving towards the numerical portion. Is it fine? आगे चलें? अरे ये तो सिंपल है. क्लियर बहुत सही. तो अब क्या करेंगे हम? We'll be finding work done in standard processes, and then I will be giving you questions on these equations and these formulas. Okay. So first of all, we'll be dealing with isobaric process. Isobaric process. Okay, isobaric process. Work interaction is equal to PdV. In isobaric process, pressure is constant. So you can take out this pressure from integration, and this will be PV2 minus V1. Okay, I hope there is no confusion. Okay. Next, isochoric process. Isochoric process. Volume is constant, so that implies this PdV term will be 0. Why? Because volume is constant, there will be no change in volume, so this dV term will be 0, and work interaction in 1 to 2 will be 0. Okay? But okay, be careful. If in the system there is some electrical work entering, or some pedal wheel work is there, or some shaft work is there, they won't be 0. Okay, they won't be 0. Only the displacement work will be 0. Please take care. Please take care. Okay, only the displacement work will be 0. Displacement work. You will have to consider other works. Displacement work will be 0. Third, isothermal process. Work interaction 1 to 2 is equal to PdV. PdV. Okay. By using PV is equal to MRT, what we can do is we can replace this P. P is equals to MRT by V. Okay. So put this here. That will be 1 to 2 MRT by V dV. Okay. M is constant, R is constant, T is also constant. It is an isothermal process. Okay. So this will yield the result which will be equal to MRT ln V2 by V1. Now a wide variety of formulas can be formed in this process by using P1 V1 is equals to P2 V2, and by using PV is equal to MRT. Okay, this MRT can be replaced by this term PV. Okay, either P1 V1 or P2 V2. Okay, and this V2 by V1 can also be replaced by the ratio of pressures. How? See here, P1 by P2 is equals to V2 by V1. Okay, so this formula can also be written as MRT ln P1 by P2. Okay, so there can be different formulas for this process. You have to see in the question which data is given and what formula you have to apply. Okay, clear? Let's move on to the next process, polytropic process. that is represented by PV raised to the power n, polytropic process. Polytropic process. PV raised to the power n is equals to constant. Okay, so work interaction is, again we'll start with PdV 1 to 2. Correct? So P is equal to CV raised to the power n. Okay, put the value here. What you will get? 1 to 2 CV raised to the power n dV. Okay, solve this. CV raised to the power minus n plus 1 upon minus n plus 1, 1 to 2. Okay, let's move ahead. So this will be CV2 raised to the power minus n plus 1 minus CV1 raised to the power minus n plus 1 upon minus n plus 1. Okay. So what you do is you write this term like this: V2 and V2 raised to the power minus n minus CV1 raised to the power minus n V1. Okay. Now this pressure is equal to C into V raised to the power minus n. Okay. So CV2 raised to the power minus n, this is P2. Okay. And CV1 raised to the power minus n, this is P1. This is minus n plus 1. Okay. So adjusting the sign, we will get this relation. Work interaction in this case will be P1 V1 minus P2 V2 upon P2 V2 upon n minus 1. This will be the formula. This is how you get the result. Okay, this is how you get the result. In the case of adiabatic process, this n is equal to gamma, and work interaction formula becomes P1 V1 minus P2 V2 upon gamma minus 1. Correct? Okay. Correct? Tell me in the comment section, and then we will be moving on towards the numerical part. Come on. Tell me in the comment section. ठीक है, समझ आया? तो 2 क्वेश्चन होंगे प्रीवियस ईयर गेट के और 2 होंगे कन्वेंशनल ईएससी कन्वेंशन. ओके, ठीक है, प्रैक्टिस करना है और मुझे आंसर देना है. Write the answer in the comment section. Okay. So the first question on your computer screens. Solve this. Only 1 minute. This question should take only 1 minute. Only 1 minute. Give me the answer. Take out your calculators. I want everyone to solve this question. I want the answer in 1 minute. This is a very simple question. Previous year GATE question 2009. Without practice, you will not be able to clear any exam. Okay? Solve this question. Even if your concepts are clear, you will not be able to apply those concepts if you have not practiced enough. If you have not done enough practice, you will not be able to ace this exam. Give me the answer. Give me the answer, come on. You're taking too much time. B is not correct. B is not correct. B is not correct. Let me check the answer. I think B is not correct here. B is not correct here. How will you solve it? It says that a frictionless piston cylinder device contains a gas initially at 0.8 megapascal, okay, and 0.015 meter cube. So initial pressure P1 is 0.8 megapascal. Okay, I try to work in SI units, so I'll be working in SI units, and then I will be, whatever answer I'll be getting, I'll be converting it in kilojoules. And V1 is 0.015 meter cube. Okay, it expands quasi-statically at constant temperature. Okay, so it expands quasi-statically, keyword, at constant temperature. That means we can use the formula which we have derived in the in the case of the isothermal process, and it expands to a final volume of 0.03 meter cube. The work output during this process will be, so directly you can use the formula, that is work interaction in 1 to 2 is equal to, you have been given P1 V1, so use here P1 V1 ln V2 by V1. Okay, correct. So 0.8 into 10 to the power 6 Pascal. Okay, V1 is 0.015 meter cube. Ln V2 is 0.03 upon 0.015 meter cube. You solve this. This will be in joules. Okay, you solve this. I guess you will be getting A, option A. Yeah. Please check your calculation again after solving this. I guess you will be getting A answer. Got it? Okay, yeah. So 8.32 kilojoules. It will be 8.31 something if I remember. So A is the answer. Correct? Clear? Let's move ahead. Okay. This was a very simple question. 1 mark question here. 1 mark question. Very simple question. 1 mark question. Okay, solve this. Solve this question. 2 marks. I'll give you 2 to 3 minutes to solve this question. Solve this question right away. Yes, A was the answer. A was the answer for the previous question. Previous year GATE question 2010. Year 2010. करो solve करो. Why are rest of the people not commenting the answer यार? चाहे गलत आंसर दो, but answer दो. I want the answer. चाहे गलत आंसर दो, doesn't matter. What matters is that you should attempt this problem. This is your DPP, daily practice problem. Huh? DPP going on, daily practice problem. अरे attempt the question यार. Swajit Wani, A. Let others comment also. 1 more minute. One more minute. Okay. So the question says that a monoatomic ideal gas gamma is 1.67 and molecular weight is equal to 40 is compressed adiabatically from T1 to P2. Okay, so P1 is given, T1 is given, and P2 is given, and it is compressed adiabatically. Keyword: the universal gas constant is 8.314 kilojoule per kilomole Kelvin. This is universal gas constant. Again, be careful. The work of compression of the gas in kilojoule per kilogram. You have to find the work of compression of the gas in kilojoule per kilogram. Okay. So you have derived this formula, this P1 V1 minus P2 V2 upon gamma minus 1. Okay. By use of the ideal gas, we can write mR T1 minus T2 upon gamma minus 1. Okay. But please be careful. Here R is what? R is characteristic gas constant. Okay. Characteristic gas constant, not the universal gas constant. Okay, take this m here in the denominator. So this equation becomes work interaction upon m. That means kilojoule per kilogram. And in these units, you have to find the answer. Okay, so this is R T1 minus T2 upon gamma minus 1. I know gamma, I can find out R. How can I find out R? R is equal to R bar by M. Okay, so that is 8.314 kilojoule per kilomole Kelvin, and this is 40 kilogram per kilomole. The units must be given here, kilogram per kilomole. Yeah. Although it is understood, but still. Okay. So this is now R. R is 8.314 upon 40. This is the characteristic gas constant. Okay. Now I know T1, I know P1 and P2, and I know this process is adiabatic. We have one more relation, that is T2 by T1 is equal to P2 by P1 raised to the power gamma minus 1 upon gamma in case of an adiabatic process, right? Correct? Correct. So T2 is equals to, T1 is 300 Kelvin, P2 is what? 0.2 megapascal, and P1 is also in megapascal. So no need to change it in pascal, because in 10 raised to 6 in the numerator and in the denominator will get cancelled. Okay, so 0.2 upon 0.1. Gamma is given 0.67 upon 1.67. Solve it. You will get T2 around 395 or 396 Kelvin. I don't remember the exact value. It will be approximately 395 or maybe 396 or maybe 396 Kelvin. Somewhat around this. Okay. So now what you have to do is, put this T here, put this T here, put this T here. Let me add a slide. So work interaction upon M. This is in kilojoule per kilogram. You have to find this in kilojoule per kilogram. Okay. Kilojoule per kilogram. So take care. Yeah, what units are you are going to put here in this R. Okay, this is kilojoule per kilogram Kelvin. So you will get your answer directly in kilojoule per kilogram. Okay. If you ever get confused about the units, just write down the units with the values. Okay, so 8.314 upon 40. T1 is what? T1 is 300, I guess. 300, yes, and T2 is I guess around 396, so let me write 396, and gamma minus 1, that is 0.67. Okay, so you will get option A as your answer with a negative sign. That means Your answer is correct because the work of compression is given. That means you will be getting the answer with a negative sign only. Okay, so A, in this case A is the answer. Is it fine? These were very simple questions. Okay, 1 mark and 2 marks questions. These were very simple. Is there any doubt in these questions? Please ask me if there is any doubt in these two questions. Please comment down below if there is any doubt in these two questions. If there is no doubt, solve this question. Solve this question. Conventional question. You have doubt in unit conversion? Okay. Tell me the doubt, please. बाकी लोग ये सॉल्व करो यार. बाकी लोग ये सॉल्व करो. And what is your doubt? कहाँ पे डाउट है? कौन से यूनिट में डाउट है बताओ. कहाँ पर डाउट है अर्जुन? Others, please solve this question. I'll give you 5 minutes to solve this question. Please solve this question in real gas equation. Okay. रियल गैस इक्वेशन में क्या डाउट है? देखो मैं बता देता हूँ तुम्हें सारा कुछ. PV is equals to N R bar T. If you use this equation, okay? If you use this equation, see R bar is in kilojoule per kilomole Kelvin. Okay? T is in Kelvin. N is in kilomole. ठीक है? P is in Pascal and V is in meter cube. Okay. Now what we did is PV is equals to molecular mass of the gas upon molecular mass of the gas. Sorry, mass of the gas upon molecular weight of the gas. M R bar T. Okay. What we did? We combined these two terms and now PV is equals to M R T. Okay. This is characteristic gas constant. Now this becomes characteristic gas constant. Okay, see R bar is in what? Kilojoule per kilomole Kelvin. Correct? Upon M, molecular weight is in kilogram per kilomole. So this kilomole gets cancelled out. So the units of characteristic gas constant is kilojoule per kilogram Kelvin. Okay, and in this equation also P is in Pascal and it is absolute pressure. This is in meter cube, this is in kg. Okay, this is in kilojoule per kilogram Kelvin and this temperature is in Kelvin. Understood? Understood? Also in 11th class we used to have we were using these units where we used to put V in liters and P in ATM. Okay, in that case the value of R was 0.0821 and the units will be this will be liter ATM upon mole Kelvin. Correct? Correct? Those who have joined now, please mark the attendance and solve this question. Okay, great. You write it down, okay? You write it down in your notebook. For any kind of doubt here, you can contact me on FB. Any kind of doubt, even regarding to your career, you can ask me anything. Are you going to solve this question or not? 3 more minutes. Arjun, I will rub this off because I have to use this space. So please note it down in your notebook. Or I will, okay, I will use the next slide. This will be helpful for other students as well. So I will use the space in the next slide, okay. Solve this question. Give me the answer of V2. Come on, yaar. V2 is 1.4859. Just let me check the answer. Yes, you're correct. V2 is 1.485 meter cube. Correct. Very good. Come on, give me the answer of the second part, that is network transfer. अरे बताओ रे, जल्दी बताओ. क्वेश्चन सॉल्व नहीं करोगे तो पेपर नहीं निकलेगा. अच्छा खासा क्वेश्चन है, सॉल्व करो इसको. 10 मार्क्स. ESE मेंस. Noted sir. Okay. Good यार. सॉल्व करो इसको, सॉल्व करो. Swajit, yeah, give me the answer, yeah. Network transfer. Come on, solve the question. One more minute. Question says that 1 to 2 is isobaric process, 2 to 3 is adiabatic, and 3 to 1 is isothermal. 3 to 1 is isothermal. You have to find V2 and the network transfer. Okay. How we will proceed? You know P1, you know P2. Great. You know V1 and you have to find V2. Okay. But this is a constant pressure process, yeah. You know nothing about the temperatures. Okay. Let's move on to the next process. So you know V2, no. We don't know V2. Do you know V3? We don't know V3. But we know P2 and we know P3. अरे P2 पता है, P3 पता है, but V2 और V3 नहीं पता है. Okay, so we cannot use this relation. Correct? अभी उसके बाद क्या करें? Let us move on to this process. Work done आ गया 125.75 kilojoule. Good यार, kilojoule. Good यार Swajit. There is one more question for you. Just let me solve this question and I'll give you that question. The next question. Okay. So let us move on to this process 3 to 1. Okay. This is isothermal process. PV is equal to constant. We know this P1. Okay. And we know this P3. We know P1, V1 and P3. So yes, we can apply this relation here, right? How? This P1 V1 is equals to P3 V3. Okay, P1 is what? What is the value? It is 400 kilonewton per meter square. So 400 into 10 to the power 3 V1. V1 is 1 meter cube. P3 is 100 kilonewton per meter square. Okay, and this is V3. This gets cancelled out, and V3 is 4 meter cube. Now I have V3 with me. I have V3 with me. Okay, I have P2, I have P3, I have V3. Can I find out V2 by using this relation? Yes, yeah. I can find out V2. How? P2 V2 raised to the power 1.4 is equals to P3 V3 raised to the power 1.4. Okay, what is this P2? P2 is equal to P1. Are a constant pressure process here. Okay, so this is 400. I'm not going to change this kilonewton per meter square into Newton per meter square now, because this 10 is per 3 here and here will get cancelled out. Okay, V2 is what you have to find is equal to P3, that is 100, and V3 is 4 raised to power 1.4. You solve this, you will be getting V2 is equals to the answer given by Swajit was right, that is 1.4859 meter. Okay. Okay. So for net work transfer, what you do is you find work interaction from 1 to 2. How will you find that? This is a constant pressure process. So in a constant pressure process, the formula of work interaction is P V2 minus V1. That is V final minus V initial. Okay. So what is the pressure? Pressure is 400 kilonewton per meter square. 400 kilonewton per meter square. Okay, I'm not going to change this kilonewton per meter square into Newton per meter square. Okay, because if I write this 400 kilonewton per meter square, I will get the work interaction directly in kilojoule. Okay, if you have any confusion, you can change the units into SI units. Okay, this V2 is 1.4859 minus 1. V1 is 1 meter cube. Okay, so you'll get the value. Let me check the value. This will be 194.397 kilos. Okay, let's move on to the next process, that is work interaction from 2 to 3. This is an adiabatic process, and in the case of an adiabatic process, what is the formula? This will be P2 V2 minus P3 V3 upon gamma minus 1. Okay, and gamma is 1.4. It's given 1.4 minus 1. Okay, what is P2? P2 is equal to P1. Okay, 400. Again, I'm directly putting this in kilonewton per meter square, so that my work interaction will directly be in kilojoule. If you have any confusion, you can change it in SI units. Okay, don't worry about that. So 400 V2 is 1.4859. What is P3? See here, P3 is 100 kilonewton per meter square. So 100 into 4, okay, upon 0.4. You'll get the answer as, let me check the answer, 485 kilojoule. 485 kilojoule. Okay, let's move on to the next process, that is isothermal process. Okay, and in case of isothermal process, what is the formula of work interaction? Okay, either you can use this P3 V3 ln V final upon V initial. Okay, or you can use P1 V1 ln V final upon V initial. Okay, what is this? ln is natural log here. Okay, yeah, so I will use this P1 V1 natural log V final upon V initial. Now in this process, V final is V1 and V initial is V3. Okay, V final is V1 and this V initial is V3. Okay, put the values. So 400 and V1 is 1 meter cube. 1 meter cube, yes, it is 1 meter cube. Yeah, ln V1 is 1 meter cube, V3 is 4 meter cube. You will be getting your answer as minus 554.517 kilojoule. Okay, so net work transfer will be what? Net work transfer will be 1 plus 2 plus 3. Okay, and the final answer that you will be getting is will be 125.75. Yeah, 125 or 124.879. Yeah, approximately around 125. Okay, 125.8 kilojoule. Approximately. Okay. Correct. Any doubt in this question? आगे चलें. Solve this question. Come on, solve this question. Amazing question. Means 10 marks. Come on, solve the question. Come on, solve this question. Try this question once. TPP question number 4. बढ़िया क्वेश्चन है, ट्राई करो यार, थोड़ा सिस्टम का कॉन्सेप्ट क्लियर होगा. Read it carefully. The net work done by the fluid. Okay, so if you're trying this question, keep on trying. Okay, keep on trying, and we'll discuss this question in the next class. Keep on trying this question, as I'll be telling you the benefits of the plus subscription. Keep on trying this question. Click the photo of this question. Click the photo, and then I'll be telling you the benefits of some the plus subscription, and these type of questions. This is what we are solving in the plus in Unacademy Plus platform. We are solving GATE previous year questions, ESE mains questions. We're doing a lot of practice here. I've already started thermodynamics, and we're solving a lot of questions in the class, because practice is of utmost importance. Sorry, and if you won't, if you won't do enough practice, you will not be able to solve the questions in the real exam, the exam that you will be giving in February. Solve a lot of questions there on Unacademy Plus platform, and the interface is much better there. Okay, we'll be discussing this question in the next class. Okay, and I will be putting up the notes of this lecture on our Unacademy GATE ME Telegram group. GATE ME Telegram group. So join this Telegram group for the notes of these of this lecture. Join the Telegram group, or you can ping me on my Facebook profile. Okay. If you are trying this question, keep on trying. Tell me the answer. If you get the correct answer, tell me the answer. will be I mean I'll tell you whether your answer is correct or not. Okay. So we have daily live classes on Unacademy Plus platform, and after completing your syllabus, we'll be starting a crash course, and this is included in this subscription. Okay, RIB batch starts from 15th June, guys. 15th June, and mission batch in Hindi and English is going on. Okay, every fourth class is a doubt clearing session. And we have weekly quizzes over there. Weekly quizzes, and the interface is much better. Yeah, the interface is much better. The interface of Unacademy Plus is much better. I have to read your comments on my phone in YouTube, but in Unacademy Plus platform, what I can do is I can read your comments on the screen itself. So I'll be able to answer every doubt of yours. Okay. Next, this is the name of our batch, mission batch. Mission batch. Please do not forget the name of this batch. Okay. We launch our batches under the name mission, and we have already started the batches in English and Hindi. I'm taking thermodynamics, basic thermodynamics from 9:30 a.m. to 1 p.m. Okay, and Alok Jha sir is taking engineering mechanics in Unacademy Plus platform from 8:30 p.m. to 10 p.m. Okay. This is what the interface looks like. You can see me here, and these are your comments that I'll be able to read, and this is my whiteboard, or whatever you can say it. This is the working area. Okay, so this is the interface. Interface is amazing. Interface of Unacademy Plus. Unacademy Plus is amazing. There will be better interaction between you and me. Okay, and we have launched a lot of batches here, a lot of batches. Even we are going to launch RIV batch. So the syllabus will be completed in this RIV batch and other batches by mid-November. They are full-fledged batches. Okay. Next, as I've already told you that every fourth class is a doubt clearing session. So every doubt of yours is answered in Unacademy platform. Every fourth class is the doubt clearing session. Okay, and when I can conduct a live poll in the Unacademy platform, and it is not available on YouTube. That cannot be conducted on YouTube. How to purchase the Unacademy subscription? You go to unacademy.com website or the app, select your goal as GATE and ESE, and click on Get Subscription if you want to get the subscription. These will be the plans: 1 month, 3 months, 6 months, but 12-month and 24-month plan will be very beneficial for you. It is cheap as compared to 6-month or 3-month or 1 month plan. Okay, it is very cheap as compared to these 3 plans. Okay, and upon applying my code, that is Viresh 10, you will be getting 10% off. 10% off. So 1 year plan will be of 22,500, and 24-month, that is 2-year plan, will be of 27,000. Okay, and as compared to 1 month plan, see, this is really affordable. You're getting 1 year subscription in 22,500 rupees, whereas 1 month subscription is of rupees 4,500 after applying the discount. Okay. Okay. You can have the EMI option on credit cards and 1 debit card if you have a debit card of HDFC. So this EMI facility is available on HDFC debit card as well. Okay. Do not forget to apply Viresh 10. This is my code. Do follow me on Unacademy for more free special classes. and my courses. Okay, do follow me on Unacademy. I'm there by the name Viresh Kumar. Okay. This is the doubt solving group that I was talking about. GATE aspirants MECE CSC. MECE CSC. Okay. We have hired interns especially to solve your doubts. Solve your doubts. You post your doubts in this group, and they will solve your doubts as soon as possible. Okay. So do join this group. GATE aspirants MECE CSC. GATE aspirants. GATE aspirants MECE CSC. This is our Telegram group in which we post the PDF of these lectures, these YouTube lectures. Okay, so do join this Telegram group, that is Unacademy GATE and ESE. Okay, for notes, for daily quizzes. Okay, do solve this question here. Do solve this question. We will discuss this question in the next lecture. Do try to solve this question. Okay. This is how you can connect with me. You can get connected with me. My Facebook profile is Viresh Kumar. You can ping me here for any type of query. कोई भी मुसीबत हो यार जिंदगी में कॉल कर देना. I mean call, sorry. Facebook पे मैसेज कर देना. Okay. Do ping me here. Or you can also message me on my Unacademy profile. कोई भी दिक्कत हो करियर के रिगार्डिंग, गेट की प्रिपरेशन कैसे करनी है, ईएस की प्रिपरेशन कैसे करनी है, दोनों मैनेज कैसे करने हैं, कोई और दुख हो जिंदगी में, you can message me here on my Facebook profile or on my Unacademy profile. Okay. और Instagram पे भी अगर करना चाहते हो तो you can ping me there also. Okay. Do follow me on Unacademy for free special classes. Free special classes. Do follow me here. Correct? Before ending the class, I am again saying that I'll be putting up the notes on that Telegram group, or you can directly ping me also for these notes, and try to solve this question. I'll be discussing this question in the next lecture. Okay, try to solve this question. तो यही डिसाइड किया था मैंने इस लेक्चर के लिए. इस क्वेश्चन को ट्राई करना यार, अच्छा क्वेश्चन है, छोड़ना मत, प्रैक्टिस किया करो. ये नहीं कि सिर्फ कॉन्सेप्ट समझ जाना और प्रैक्टिस नहीं करनी है. इफ यू वोंट प्रैक्टिस यू विल नॉट बी एबल टू क्लियर गेट विद अ गुड रैंक. ओके, तो प्रैक्टिस करो इस क्वेश्चन की. एंड इफ यू वांट टू जॉइन Unacademy Plus सब्सक्रिप्शन यू कैन पिक मी ऑन माय फेसबुक प्रोफाइल. और इफ यू हैव एनी डाउट यार, एनी डाउट रिगार्डिंग एनीथिंग, कोई भी प्रॉब्लम हो, you can just share it with me. You can just share it with me. You can ping me on my FB profile, on my Unacademy profile. Okay, then see you guys. Yeah, bye bye.